with the next presentation, and if anyone has any questions, maybe in the end we would have time. Now I would like to invite with great pleasure the next speaker, Professor Arno Fruehwald from Hamburg University, and it is a pleasure to meet you again here. And Professor Fruehwald will present us about the coconut wood properties, processing, and products. So, Prof. Fruehwald, the stage is yours.
Yes, thank you, Ali, for introducing this presentation. Ladies and gentlemen, welcome back. Good afternoon, or still good morning in Europe. And I would like to have the privilege to talk to you again today on coconut processing, and more from an industrial perspective. As I explained on Monday, I've been working with coconut since many years, and later I switched to oil palm, and many things we have learned for oil palm processing could be used for coconut processing more from the industrial point of view. As Mr. Kiln pointed out, he deals with the more traditional rural processing and utilization. So I would put more emphasis on, can we use coconut palm as an industrial material, even partly industrial material? I have to apologize, my co-author, Katja Fruehwald-König, she is in another meeting, internet-based meeting, and her meeting is delayed, so she may change, he may come later. So I have the privilege to talk to you, maybe all the time today. Okay.
Prof, Prof. Arno, your slide is little bit, it's not fully coming to us.
It's not fully coming to you.
Yeah.
Okay. It's fully with me, but I will try it again. Okay.
Yes, yes. Now just you make full screen again.
Yeah, moment. Just a moment. It's better now.
Yeah, it's better, but still is something is cutting. Means is the slide is coming. Yeah, now it's okay. That.
Now it's okay. Okay.
Thank you.
I would like to talk a little bit about properties related to industrial use, then generally product groups we can use, we can produce in industrial processes. Then the availability of coconut trunks has to do with industry, and in the processing technologies, the capacities we need for an industrial level. And then some of the favorable products we have in mind, and finally the conclusion. So you know very good and very well, and you have heard the density variation is a big challenge. So we need special sawing patterns. We have lumber of different qualities, of different densities and different qualities, similar to the oil palm we discussed already on Tuesday. We have to do a very careful grading of the material to get from the density distribution the correct material for the different uses. So the grading also with the coconut, if we try to get the best products possible out of the material, is a very important aspect. So we can do visual grading, and we did a very big grading study some years ago. Visual grading according to experience. So very well-trained people can look on the material and say, well, this is this density, that density. And if you know the position is in the trunk, it is from the lower part, from the middle part, or from the upper part, we have quite a good feeling what to do. But this is not enough for product separation and product property optimization. So we have various semi-mechanical possibilities for grading. So we can take weight and volume, and then we get the overall density of a piece of lumber, for example. Or we can measure the deflection with a MOE testing machine, continuous MOE testing of lumber, for example, which is used worldwide for softwoods, for example. Or very, not primitive, but easy methodology is nail incising and the depth of the penetration of a nail is correlated, for example, with hardness and density. So this is also quite good information. Or the more sophisticated grading technologies, as we already discussed, or Katja Fruehwald discussed on Tuesday, is the X-ray for density distribution in length and across the board, or for ultrasonic or wave propagation, which is very much correlated to MOV. So already Wolf Kilman has mentioned the difficult drying of wet lumber. So we need quite a rapid drying process because we have the risk of mold and fungi and blue stain. And we have to consider, if we are not rapid enough, then we have to consider surface protection of wet coconut wood. There are some possibilities, very primitive possibilities like acid, or chemicals, even not too bad chemicals. We can get about between some days or even 2 or 3 weeks between, for example, sawmilling and start of drying. The drying itself, as air drying is possible, is done quite often, but the drying schedule is very hard to control. And so we have a lot of risk of defects. Either if the humidity is too high for a long period, then we have the risk of blue stain, mold, and fungi and insects. If the sun is too high and temperatures are too high, then we have the risk of splits or even other very severe cracks, for example. Kiln drying is for industrial uses more or less a must, and the investments are high, that's quite clear. But overall, the costs are quite moderate because we have very limited drying times compared to air drying. For air drying, we need at least 3 months to 6 months to get equal level of humidity and moisture. And we have done drying in Indonesia and Malaysia quite a lot with 1 inch thick material between 10 and 14 days with a very high percentage of recovery. Recovery means almost defect-free. And for 2 inch thick material, more from the inner part, we need 3 weeks to 4 weeks, 30 days with a 90% recovery rate. And even the recovery rate could be higher if we use the knowledge we gained from oil palm drying. The drying costs we measured later, or we calculated later, is between $40 and $70 per cubic meter. This is very high at the pretty moment, but if you look to the very high recovery rates, you get with a defect-free material, the costs are appropriate with kiln drying. So the other processing of lumber is difficult, as we already know and have learned, the high density variation with partly high cutting forces, especially on the vascular bundles, which produces very rough surface because of the very soft parenchyma. We need the tool design, as Mr. Kisselbach explained us on Tuesday, and we have the high abrasion of knives. So as Mr. Kisselbach told, the best material for saw blades, for cutter heads and drilling equipment is special formulation of tungsten carbide, which is quite difficult to use in bandsaws. So bandsaws, as Mr. Kilman pointed out, stellite tipped saw blades are standard at the moment. But maybe in future also we'll see tungsten carbide tipped. And we can learn a lot from oil palm processing nowadays. So the gluing is as similar as, a bit easier as the gluing of oil palm wood. The surface is still rough. The parenchyma is soft and we have quite large cell lumina. So we need a special type or a special formulation of glues, for example, for this. PVA with a high solid content, it performs very good, or the well-known urea or melamine or phenol formaldehyde, We have to use fillers to avoid deep penetration into the material, especially in the parenchyma. As Mr. Henniken pointed out on Tuesday, polyurethane, one formulation polyurethane, is quite good because it has a quite good expansion characteristic, but also the penetration is quite heavy, deep penetration into the vascular bundles. So, and the polyurethane is rather expensive compared to the others. So this is certainly for some of the products I will mention later, quite a good solution. So in general, the increased glue application is necessary, and the best is on both surfaces with quantities of between 250 and 300 grams on both sides together, so 100, 125 on one side. And then use a partly expandable glue with a high solid content, so to avoid too deep penetration into the parenchyma. And we should have good and flat surfaces, not necessarily planed. If you have good sawn surfaces, could even get better shear properties, because we have some kind, if you have sawn surfaces, they're a little bit rough, and you have partly fiber filled glue lines. So surface treatment is more or less easy because the wood in general is of higher density. So we have two possibilities: varnish, non-film overlays, and lacquers with closed film overlays. I personally prefer the varnish, this non-film overlays. Use several layers with increased solid content. This can be used for exterior, and this allows regular maintenance, quite easy maintenance. Of course, closed film lacquers are in one way or the other better for rain, for example, but the risk here is that we have still a shrinkage and swelling in the parenchymatic zones of the wood if we use it outside, and so the risk of cracks in the film is quite high. So if we look on some kind of a conclusion for the property and densities, so we need the processing according to density. We need special tools. We have good recovery rates for coconut wood, quite good, and this has a positive influence on the costs. Also, the costs of processing are some 25 to 40% higher compared to low and medium density common timbers like lawan, for example. But due to the good properties of coconut wood, we can save material in volume, and this reduces the cost of the final product at the end, maybe up to 20%. So the overall costs generated from the material itself, material costs and the processing, maybe 10 to 20% higher than compared to a medium density common timbers. So if we come to some examples for products. So we have in general three types of products, the solid wood based products like single and multi-layer solid panels or door inlays only from the lower densities. We have construction material, beam type like glue lamp, for example, GLT, or panel type, 3-layer, 5-layer, and so on, like the cross-laminated timber. And then floorings is quite a good market, as already Wolf Kilman explained. We concentrated in our research on multi-layer floorings with a face layer of coconut, and door and window frames. I will show you some pictures, and furniture. And these solid wood products have quite a good opportunity to bring the good properties of the material in service. Then we have, in general terms, the veneer type products like plywood. Dr. Loh, the day before yesterday, explained the status of oil palm-based plywood. So with the veneer production from coconut is even more difficult because the density is higher. So if we peel veneer or slice veneer, we get a lot of splits and cracks. So this is not really an industrial opportunity here. And reconstituted panels like MDF, the problem is for MDF and particle board, we have seen this today as well from France. In France, we get a very high amount or relatively high amount of fine material. So this increases the glue demand and reduces the board quality. So my recommendation is, it's not the first place. And you will see also from the quantities we need. I refer to this presentation from Algeria. The quantities we need for an MDF or particle board plant are so very high, and so we have very long transport distances. OSB, we produced OSB from 100% coconut wood and in mix with other species, even European species. We had an excellent product quality with OSB, but the same, a modern OSB plant needs about 300, 400, 500,000 tons, a very modern OSB plant, 300,000 tons of material. Okay, if we now look on the availability, Dr. Kilman already showed the diagram. So I just refer to the three main countries, Indonesia, Philippines, and India. The potential volume is 6 million, 5.2, and 5 million cubic meters. So this is totally different to oil palm. So if we talk about industrialization of coconut timber, then we are in another category compared to oil palm. Oil palm, we talk about hundreds, thousands of cubic meter per mill. Here we have to talk about much less. So just an idea and some calculation we did in the past. So if we take 1 hectare of plantation, we have the 100 to 120 or 130 trunks, and we have 1 cubic meter per trunk. We have a rotation period. So the availability per year and hectare is approximately 1.5 cubic meters. Of course, we get it after 70 years. Then we get 70 times multiplied with 1.5, we get about 100 to 120 cubic meters. And if we talk on industrial use, I assume that we use the whole trunk, not as Mr. Kilman pointed out. Traditionally, only 2/3 of the lower trunk section was used. We are talking here about the full trunk because we can take the softer material from the top, for example, as core layer for laminated products. Therefore, I always calculate with the full trunk. So if we think, for example, of a sawmill with modern design and effective productivity, we talk, let's say, of 30,000 cubic meter of trunk input per year. For those having listened to Dr. Möhringer on Tuesday, his smallest setup of a sawmill was 30,000 cubic meters. So if we take the 1.5 per hectare and year and need 30,000, we need theoretically 20,000 hectares of coconut plantations to supply one of the sawmills, theoretically. But due to different circumstances, practically we need 50,000. That's my calculation, to have a constant supply, which is very important. If we have a chainsaw, if he doesn't get a trunk to saw one day, okay, he may do other things. But if you have a sawmill and a processing line, you have to have trunks every day in the correct amount. So I calculate with 50,000 hectares per 30,000 cubic meter sawmill. So this is has to do with plantation density. This has to do with transport distance for a continuous supply. So if we look now to the availability and we take some areas, it doesn't make sense to talk of whole Indonesia because Indonesia is so big. So the transport distances from one island to the other island would be too far. So if we, for example, look to North Sulawesi in Indonesia, we have 280,000 hectares of coconut. 20% of the land in North Sulawesi is covered with coconut. So it's the most dense plantation area in the world. So the availability would be 420,000 per year in total. So this would give 8 mills to supply 8 mills. 8 times 50,000 is 400,000. And if we calculate the transport distance is between 30 and 50 kilometers, if we locate the mills distributed within the region of North Sulawesi. So there would be a potential, theoretically, practically as well, of 8 mills. And they would consume a bit less than 40% of all coconut trunks available in North Sulawesi. If you look to Riau on Sumatra Island, 420,000, this is the rather big or rather large area. With 630,000, theoretically would give 12 mills, but as the province is much larger, so the transport distance is up to 100 kilometers, even if the 12 mills would be distributed within the province. If it is all on the seashore, then it is even much more here. And East Java is similar, 5 mills, the quantity like North Sulawesi would be also give a transport distance. So just these 3 examples for Indonesia. The best situation would be in Northern Sulawesi, and Northern Sulawesi is very well known for coconut trunk processing. So the technology for such a sawmill, just to give you an idea, a bandsaw with a lock carriage has this capacity. A twin bandsaw with a transport chain for the trunks has 12 cubic meter per hour capacity. And a double arbor circular saw with transport chain has this capacity. So, and investment and processing capacity aspects, a double arbor circular saw will be the best technology, to my understanding, to our understanding from my group. Kiln drying, a sawmill of 30,000 produces 20,000 cubic meter of dry lumber. If we calculate a drying time of 14 days, we need a net drying capacity of 1,000 cubic meter.
Patno, just sorry to disturb you. The 3 minutes is left for you.
Okay, thank you for the 5 minutes, Dr. Jawad. We need 5 kilns. So this is feasible, it's not a problem. And lumber processing, we can take all the technology from the oil palm processing. So just a few examples of industrial made products. This is a 3-layer cocoa wood panel, 30 millimeter thick in this case. This is the piece of glue laminated timber of high density coconut, very, very excellent properties. This is a window we produced already 29 years ago. It was 10 years in service and then in the lab. You see a part here. This is the outer side. There's a small attack of fungi, 10 years in service. And flooring, 3-layer flooring with very excellent qualities. And your next holiday destination, Bali, the Grand Hyatt Regency in Bali, with a conference center totally built of coconut. So composites to optimize products. This is the aim of our thinking when we talk about industrialization, to optimize product properties and appearance and widen the material input. So what we see is we have a number of good properties and a number of low properties. For example, compression and shear properties are low. Therefore, the idea is, and I come to the end, Mr. Chairman, window frames, laminated window frames, for example, high density coconut, medium density coconut, and teak. This is a special advice to Thailand. Thailand has tremendous plantations of teak in northern Thailand. Why not producing laminated window scandlings or door scandlings in this combination, or glued laminated timber in the compression zone, as compression is lower flow properties with coconut, Meranti on one side, and as further down to the tension zone, as more coconut you can use for the shear area, also Meranti, for example, or cross laminated timber in the same. So not necessarily only one timber species, not only oil palm wood, not only coconut wood, but combination. This is the future of industrial use. You see this here, or if you can improve the bending properties if you incise wooden dowels vertically through a panel. This is also a well-known technology in Europe. So the conclusion is we have coconut about half of the area, but only 1/5 or 1/6 of the material compared to oil palm. The processing technology is quite similar, but cocoa wood is much more decorative, and coconut wood products can supply different market segments, also in combination with other timber species. And processing is no longer a problem. We can learn from the oil palm sector, and is a quite good business at the end of the day. So thank you for your attention. If you have questions either to Dr. Kilman or to me about cocoa wood and cocoa wood utilization, I'm happy to answer. Mr. Kilman is also, he's sitting next to me, he's also happy to answer. So thank you very much.
So, yeah, thank you very much, Professor Fruehwald.
And
I think
Mr.
that was a
Chairman,
very,
best greetings to Iran.
yeah, thank you very much.
I'm happy to hear your voice.
But I'm already in Switzerland. I'm in Biel.
Okay.
Yeah, and yeah, thank you. It was a very detailed presentation. Actually, I had several questions, but to the next slide, when you move to the next slide, I saw my answer, and
Okay.
you already did a very good and well presentation. If one question comes for you, comparing cocoa wood and palm oil, which one is easier to dry, has better machining properties, and has lower processing cost?
Okay, first, drying coconut wood is easier to dry. The risk of cell collapse, for example, and the risk of severe cracks is lower. So we have done a lot of drying experiments and also industrial drying with coconut. We had no very big problems compared to oil palm wood. Oil palm wood is more difficult, but there are also solutions. Drying times may be 50% longer, and especially at the beginning of drying, you have to take much more care compared to cocoa wood. The processing of both palm species is quite similar, because the higher density of the coconut is especially referred to the parenchyma, because the parenchyma is older, the cell walls are thicker. But the thickness of the cell walls of the parenchyma is not the problem for the processing. The problem are the vascular bundles, and the vascular bundles are of almost the same number or share of the crosscut section. And the hardness, or the, let's say, the modulus of elasticity, the density, and so on, are quite similar between oil palm and coconut. In coconut, it might be maybe 20% higher density. But you see, the problem with palm processing is not the density itself, it is the mixture of density between the parenchyma and the vascular bundles, and is the ash content, and especially the silica content. And so the silica content varies quite a lot. We have seen silica content of below 1%. So this is not a problem for processing, but we have also seen silica content more than 3%, which is a big number. And this is valid for both, or for many palms, not only for the two we mentioned.
That's true. The next question comes, but we know that we are out of time. But shortly, I will ask you, is it feasible to use a mix of palm material, for example, coconut and oil palm in the area of Indonesia and Malaysia to scale up production quantities?
Yes, definitely yes. What you have to do is a good product design. For example, use the low density material or the lower density material, whether it is coconut or oil, for example, as the core. But if you have bending load on these products, then you have to be careful, because the shear strength of both palms are palms generally is quite low. So this has to be considered, but there are solutions for this. For example, upright standing core layer for door elements or thicker bending elements. And for example, the other possibility we still in mind, and we are working on this, is OSB type panels made of palms in a mix of coconut and, for example, oil palm. So there are a lot of possibilities if you have a proper product design. Then it is a good idea, as you said, to have not only maybe if you have available all types of palms, and you put the palms according to their properties into a composite product, composite type product.
Okay.
Mr.
Yeah,
Kilman?
thank you.
Okay, that's okay. You're welcome.
Ali,
So
just
thank you
because
very
we are
much.
running
Yeah,
out of time, so let's
Yeah.
begin the break.
So-
First, I thank to Prof. Arno for giving a talk on the coconut wood property processing and products on behalf of organizing committee. We are highly thankful for your sharing the idea in this by Palma 2021.